For this activity, we're going to turn an LED on and off with a push button. In the previous activity, once you plug the USB cable into the Arduino Uno, the LED turned on, but the only way to turn it off is to unplug the USB cable from the Arduino Uno. As you can probably tell, this isn't very practical. Adding a push button to your electronic circuit will allow you to control when the LED turns on and off. For this activity, in addition to all the components you used in the previous activity, you'll also need a push button. A push button is a device that lets you control when to open and close a circuit. The push button should be placed over the middle channel of the breadboard. When inserting the push button into your breadboard, make sure you insert it correctly. You should not have to bend the legs to make it fit. Let's take a look at how to correctly attach a push button to a breadboard. In addition to using a push button to turn an LED on and off, the purpose of this activity is to learn a number of different concepts. First, we'll learn what a power source is. We'll learn what a voltage source is. We'll learn how to read an electrical schematic. And finally, we'll learn how a breadboard works and how to use one. Every electronic device needs a source of power. The electric outlets in your home are an example of a power source. Plugging a lamp into your electrical outlet provides the necessary power to turn on the light bulb when you turn your lamp on. In the previous activity, we plugged your LED circuit into a power source and it turned the LED on. A voltage is defined as an electromotive force or potential difference expressed in volts. Don't worry about understanding this right now. For now, all you need to know is that electronic devices have specific voltage requirements. For example, that TV in your room or pretty much any device that you plug into your electrical outlet uses a voltage called 120 volts AC. Your Arduino needs what's called 5 volts DC supplied from the USB port. Voltage sources have a positive terminal and a negative terminal. Here are the voltage sources that you will be using in all the activities for this class. One is a 9 volt battery and the other one is a 5 volt source on your Arduino Uno. When you connect your voltage source to your electronic circuit, it's important to know which is the positive terminal and which is the negative terminal. An electrical schematic is a visual representation of how all the components in an electronic circuit are connected together. The schematic shown here is what you built in the previous activity. Each component has a symbol associated with it. Here are the symbols for all the components in the previous activity. Note that in the previous activity, we used the voltage source on your Arduino Uno, but for the example you're about to see, we will use the 9 volt battery instead. Let's try building a simple LED circuit using the 9 volt battery instead of the Arduino Uno. Notice how each physical component corresponds to its symbols in the electrical schematic. The battery is on the left, the resistor is on the top, and the LED is on the right side. Even though the circuit did work and the LED did light up, the circuit is very delicate, and if you're not careful, the circuit will easily come apart. That's why we use breadboards. As you probably noticed from the previous activity, the breadboard lets you build semi-permanent circuits. They are semi-permanent because you can always remove the components and build a new circuit. If you look at the breadboard, the red and blue lines indicate which holes are connected together. For example, the holes for A1, B1, C1, D1, and E1 are all connected together, and any components that you insert into any of those holes can for all practical purposes be considered connected to each other. The vertical lines on the sides with the plus and minus are all connected together all along the whole length of the breadboard. Again, don't worry if you don't fully understand this concept. For now, just concentrate on building the circuits and completing the activities as shown in the videos. Then later on, you can always rewatch the videos and go over what you didn't understand, and even start Googling things on your own. Here's the schematic for the circuit we will be building for this activity. It's similar to the circuit that we built in the previous activity, but we've added a push button. When the push button is not pressed, the LED circuit is not complete and it does not light up. When you push the button, the LED circuit is completed and the LED turns on. Here's a diagram of how everything will be physically connected. Once you finish watching the video, you can go back to this section to double check your wiring. Now let's build a circuit. Insert the push button so that one leg goes into E3 and the other leg goes into E5. Insert one leg of the 1 kilo ohm resistor into D3 and the other leg into D9. Insert the long leg of the LED into E9 and the short leg of the LED into E12. Insert one end of a jumper wire into A3 and the other end into the 5-volt pin of the Arduino Uno. Insert one end of another jumper wire into A12 and the other end into the ground pin of the Arduino Uno. Double check your circuit before powering it up. Then push the button and verify that the LED turns on. If the LED does not light up when you push the button, first double check your circuit and make sure everything is connected correctly. Then verify that the long leg of the LED is inserted into D9 and the short leg is inserted into D12. If that still doesn't work, try inserting a different LED. Now try building the circuit and doing the activity.